This presentation is entitled The Holy Grail of IT. In this presentation is a formal description of what I mean by Holy Grail. In addition is an example of a Holy Grail application. And finally, a description of information technology challenges that must be met in order to deliver the Holy Grail.
The Holy Grail of information technology. So, what is meant by the Holy Grail of IT? What is the definition? It's the following. First of all, it's the ability to provide Google-like query capability on structured data. Secondly, it's the ability to compute on any structured data within and across enterprise systems. Now, when you look at search engines like Google, they have the ability to query. What they do not have the ability to do is to actually perform computation. So this second definition here is an extension of what search engines like Google can do today. Let's look at the world of data. In the world of data, there's two kinds of data. First of all, there's something called unstructured data. Examples such as text that you might see in books or magazines or blogs. In order to query unstructured data, you use search engines, something like Google. The other kind of data is something called structured data, consisting of database tables that you'd find in a business enterprise systems. Oftentimes, you'll find tens of thousands of such tables. In order to query structured data, you need a structured query language, something such as SQL. Let's look at a Holy Grail of IT example, something that would be very difficult to do with a search engine such as Google. Imagine you wish to determine how many people in Illinois have an autoimmune disease. Imagine you have a graphic such as the following that shows the United States broken down into regions, regions broken down into states, states broken down into counties, counties broken down into cities, and at the leaf nodes, the names of healthcare institutions. Imagine being able to do the following. Imagine being able to take your query and to drag and drop it into a box, and to have that query request propagated to all of the descendant nodes, and then being able to execute and aggregate the results together. Now, this would be very difficult to do with a search engine such as Google for the following reason. In order to execute such a query, someone would have had to do that analysis in advance and then take that result and publish it in a text document. Only then would it be possible to execute such a query in a search engine such as Google. Okay, let's look at a second example. This is another example in the area of healthcare. Imagine you're President Obama. One of the biggest challenges you have in your administration is with respect to healthcare costs. It turns out the U.S. is the most expensive country in the world with regard to healthcare costs. Now, you might think to yourself, well, maybe that's not so bad. Maybe we do well with regard to healthcare outcomes, and therefore the costs are worth it. Well, it turns out when you look at the top 34 industrialized countries, we rank about 27th with regard to outcomes. So now, if you're President Obama, how would you solve this problem? Well, the first thing you'd want to do is basically baseline to understand how well the country is doing from a healthcare perspective. So you'd want to be able to ask, how are we doing kinds of questions. So what the administration has done is put together a set of what are called meaningful use quality measures, which are a way of asking how are we doing kinds of questions. Now, the real challenge in all of this is that it turns out it takes years to implement, execute, and aggregate the results together. Years. In the previous slide, I talked about problem solving, the notion of baselining. Essentially, what you want to do in problem solving is to take a set of questions, and based upon the answers from those questions, you want to be able to turn around and make process changes and then ask a second set of questions. And you want to iterate through cycles like that as quickly as possible. Well, imagine if you could take what normally takes months or years for a cycle to be able to reduce cycles down to hours or days. Imagine being able to take clinical insights learned from each cycle and be able to quickly apply them to clinical practices, leading to better outcomes. Imagine being to literally be able to save lives from this. In order to deliver the Holy Grail, a number of information technology challenges must first be met. First of all, there is the notion of accessibility. It turns out much data today is still in paper form. A second challenge, disparity. Information today oftentimes resides in what are called silos. A third challenge, computability. Much data today is still in an unstructured form. A fourth challenge, queryability. If you have structured data, the technology today is such that it is very difficult to navigate complex structures. Another challenge, one of fragility. Oftentimes in an enterprise system, whenever you make changes to one layer of the architecture, you oftentimes get this ripple effect where other layers break. Another challenge, one of rigidity, the inability to easily change data schemes on the fly. Another challenge, one of complexity. Oftentimes enterprise systems today are comprised of potentially tens of thousands of underlying database tables. In order to query such data, you actually have to know the names of those potentially tens of thousands of tables. Another challenge is one of evolvability. Let's say you have a legacy system and you want to introduce a new system into your enterprise. The challenge is migrating the data from your complex legacy system to your new system. Another challenge is one of interoperability. Today, interoperability is restricted to standard message exchanges. And lastly, one of expressibility. The challenge today, in order to do queries on structured data, you have to have IT skills. Over a number of talks, we're going to talk about a proposed solution to delivering the Holy Grail. In particular, we're going to talk about 4 categories of technologies. We're going to talk about information technologies, namely SQL and XML. We're going to talk about knowledge technologies, something called ontologies, which are an industry standard way of categorizing structured data. We're going to talk about natural language processing, which provides the ability to ontologically categorize structured and unstructured data. And lastly, we're going to talk about a new technology, something called TC-SQL, turbocharged SQL. It's not really a new programming language, it's really a clever use of standard SQL. In particular, it provides the notion of something called soft schema, which will be used to address the problem of complexity. I mentioned today that enterprise systems oftentimes are comprised of potentially tens of thousands of tables. This notion of soft schema reduces it by 4 orders of magnitude. A second thing provided by TC-SQL is the notion of transitive closure, which provides very fast ontology navigation. So why is providing a generalized way of executing queries on structured data a big deal? Well, first of all, I would claim that it represents the last frontier with regard to data. Over the not too distant past, there was a big push toward the semantic web. More recently, there's a big push toward big data and big data analysis, and there's still a lot of emphasis on dealing with unstructured data. I'm claiming here is an untapped opportunity. Second consideration, the amount of structured data in the world is massive. Third consideration, if you could take a random text string query, like in doing a Google search, and apply it on any structured data, that's an oh my god kind of capability, demonstrating an unprecedented semantic and computing interoperability within and across domains.